Hi everybody. So as I said, when I have a quiz or homework, instead of going through it in class on the board where you may or may not be able to keep up with me, I thought I'd do these little YouTubes and post these PDFs of the solutions. So next to this lecture in Blackboard, you should be able to find this PDF. The screen captured probably doesn't do it justice. It might be best to pull it up as well and look at it. But you see what I've got here on this screen is I've written it out. So here's the first part of the quiz. We have a capacitor with an AC voltage imposed on it. But you really don't need to know anything about circuits to do this problem. It's strictly a Calc 1 problem because what I said was the current is equal to the capacitance times the derivative of the voltage. That's all you really need to know. And I gave this equation for the voltage of it's some constant V times the sine of omega t, which is, of course, alternating current. So here you see I set it up. I said the IC is equal to C. It's a constant, the capacitance, so you can pull that out of the derivative, times the derivative of V omega t. V is also a constant. I could have pulled that out as well. And so what I have here is the current, I sub C is equal to C, capacitance, times omega times V times the cosine of omega t. Basic differentiation of a sine wave. It's d dt of sine omega t is equal to omega cosine omega t. Simple as that. But you don't forget that or it totally gets the problem wrong. So that's the answer to the first part. C omega V in any order times omega t. Now I gave you the values of these constants. I say the peak voltage, V, peak to peak, or the 0 to peak, is 200 volts. And I say it's in North America. So what I'm trying to get at here is how much you understand alternating current, which means if I said North America, hopefully everyone knows that the frequency of alternating current in North America is 60 hertz. It's not that way everywhere in the world. In Europe and in some of Asia, it's 50 hertz. And that's something that we'll just have to keep in mind, but by and large, just knowing it's 60 hertz is fine. So the other thing you need to realize is omega, which is frequency, but it's radian frequency, not cycles per second. So 60 hertz is 60 cycles per second, but to get it to be able to use that in this problem, we have to convert it to radian frequency, which means cycles per second times 2 pi radians per cycle, and we get 377. So North American power has a radian frequency of 377 radians per second. You put all that together, 0.66 MF is millifarad, 10 to the minus 3 farad. You put all together and the answer is 50 amps. And like I said in class, only one person got that answer right. If I were to sketch these two, in other words, if you're able to maybe put these on an oscilloscope where we have two different traces, they might look something like this. And again, it's a rough sketch. I wanted to do it similar to how you might do it in your own in class taking the quiz. So I drew the axes out here. Here the voltage is a sine wave. The value of V up here is 200, so that's where it's going to peak out. It comes back down to minus 200. I didn't draw that very well. It should make it all the way down there. And it'll cross this 0 again. It'll finish the cycle in 1/60th of a second. Okay, and that's what the time should be here. The current, and I should have labeled this axis to be volts or amps because I'm using the same axis for both of them. The current is a cosine function, and it starts here at 50 and then goes through and is at exactly the same frequency, but it's out of phase by 1/4 of a cycle. And that's how it would look there. So that's what I was looking for in problem 1. Like I said, it's sort of a trick question. It's not really a current or a circuits problem. It is simply a mathematics problem. So if you had a hard time with that, you should maybe take a few minutes to review your basic calculus. Okay, so I'm going to download a separate video for problem 2.